Okay, so here let's take a look at the connection here between the permutation number and then the choose number, right? So we have P and K. We've established that we can think of it as N choose K, and then the K factorial. And we saw that we can think of the N choose K as P n K over K factorial, right? So this leaves us that we can kind of think of there's some kind of quotient rule involved here, right? So for example, let's say that we had the set consisted of the numbers 0 or the digits 0, 1, 2. And we wanted to think of all of the different the permutations of the three numbers, right? So for example, 0, 1, 2, 3, excuse me. And I wanted to think of the sequences that are of length 3. So for example, 0, 1, 2, 0, 2, 1, 1, 0, 2, 1, 2, 0, 2, 1, 0, 2, 0, 1, right? And then 0, 2, 3, all right, 2, 0, excuse me, 0, 3, 2, 3, let's say 2, 0, 3, 2, 3, 0, and lastly 3, 2, 0, and 3, 0, 2. Okay, and then we also have 0, 1, 3, or 0, 3, 1, or 1, 0, 3, 1, 3, 0, 3, 0, 1, 3, 1, 0. All right, and then lastly the 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 2, 3, 1, 2, 3, 2, 1. Okay. So we could see here, and again, right, P 4 choose 3. So that's 4 times 3 times 2, right, which gives me 24. Right, so we have 24, what we'll call the total outcomes are 24. Right, now, I wrote these in these 4 rows just to, if we take a look at here, the first row here, right, and we say, well, what do all these have in common here? All right, we could say, all right, well, here, we could say that, excuse me, that what they have in common here is that they all have the digits 0, 1, and 2. Right, and it's all the different ways that we can permutate 0, 1, and 2. And we could say that there's 6 ways, right? That makes sense, right? There's 3, right? So we could think of, excuse me, that to be 3 factorial here, which is 6. Okay, so what we want to think of here is, okay, now we want to think of, well, if we group by, in this case, 3 digits, right? Now, it doesn't matter which 3, right? Whether it's 0, 1, 2, if I look at this first column, 0, 2, 3, 0, 1, 3, each one of those rows, right, has 6 entries in them, right? Because no matter how we group those 3 digits, we wind up having 6 combinations, right? So we're grouping the digits by size 3. Right, so each group must have 3 factorial. If we think of these as a group, right, the 3 factorial is 6. All right, so what the quotient principle is stating here is we want the total number of outcomes over the group size, that's going to be equal to the number of true outcomes. Okay, so here, total number of outcomes here, we have, so on the top, the way to interpret that, we have total number of outcomes is 24. The size of the group is 6. And that is equal to 4, right? And we see that we have 4 rows here, right? So the true outcomes being that, right, the subsets, right, of those 3 digits, right, there are 4 of them, right? And each one of those rows, they are similar, they are related because they all contain the same digits in that row, across the row. So the way that you can think of this, and of course 24 over 6 equals 4, that's equivalent to 4 choose 3. Right, so the way that you can think of that is for a set of size 4, if you're choosing 3 of them, right, this gives you the total number of groups that you're going to have. Right, you're going to have 4 groups of that same ordering. Right, and how long is that group? Well, that depends on, well, the size of the group, right? As we see here that in this case it was 6, right? That would be that 3 factorial, right? So here we could see how that factorial comes into play in our permutation number and the choose number, right? It kind of divides out all those different orderings and just gives us the size of the number of subsets that we have with unique elements here. Okay, think of them almost like we thought of like equivalence classes when we were doing those in an earlier section.